Hi guys, welcome back to our lesson. So we are still looking at classifying some numbers, right? This is about what type of numbers we have and how do we classify them based on their properties, right? So far we've looked at numbers that are your whole numbers, natural numbers, integers, and rational numbers. And all of these numbers fall within what we call real numbers. But now, we also have another type of number, which we then call an irrational number, which we're going to try and look at very soon. So let's just see what we still need to do. So, remember when you talk about rational numbers, right? This we said these are numbers that can be written in the form of a over b, where a and b are integers, but provided that b is not equals to 0. Y must not be equals to 0. Remember the thing that I asked you to do, which I'm also going to quickly do now. I said choose any number. So I'm going to take 9, right? Any number. Divide this by 0. And if you have a specific answer on your calculator, please make sure you find me. I will give you all the money you want in the world. Because this will give us what we call a math error, right? Why math error? Let's just try and investigate that a bit, right? All the numbers we said, they cannot be rational numbers, right? Because you can see that I cannot divide by 0, and 0 is part of the integers. So if I'm dividing by 0 and it does not give me a number, then what numbers am I now introducing now? So these are types of numbers that are going to be called complex or imaginary. But before that, I want us to talk about the irrational numbers, right? So this, if we use an operation of a square root or a cube root, right, with on positive integers, what do we get? Let's play around with some numbers here. So let's say square root of 2, square root of 4, square root of 6, square root of, or cube root of rather, 2, right? And then the cube root of 8 as well. I will write it here, the cube root of 8, right? And then another one, cube root of maybe 27. So let's just play around and see what numbers we are going to get here, right? So the first one was cube root of 27. So that's going to be, let me just erase that thing there. Cube root of 27, that gives me 3. So that's a whole number. Just memorize that for me. And then I also have a square root of 2. That gives me square root of 2. If I want the answer, a lot of digits that I have here. So let's quickly just try and do this. So this will be 3, and this we found it to be 1.412, 1,4142,423. You see, so now there's a lot of different numbers that we have here. Another number will be, if I want to find what is the cube root of 8, I find 2, so that's a whole number. Square root of 4, I find 2. So it means, if I play around with these square roots, some numbers give me numbers that I've already classified before, right? So I can always go back there. But what about these ones that are not giving me numbers that I've classified before? Because this is not recurring. It's not even terminating, because it has a lot of decimals, and those decimals are not following any pattern. So as a result, we then have what we call irrational numbers, right? And these are numbers that are said to be non-terminating numbers, and also they are said to be non-recurring numbers, right? Non-terminating meaning this one has an infinite number of decimals, right? Infinite number of the decimals. That's what non-terminating means. And then non-recurring will mean no visible pattern, right? No visible pattern in the decimals. Pattern in the decimals. And then these cannot be expressed as a ratio of integers because you can't get a specific number to say if I divide it by this, it will give me what I want to find. So that's why we cannot say these can be expressed as a ratio of integers. So meaning you can't write this as A over B. Why? Because it must be a number that's not that's non-terminating and non-recurring. So irrational numbers, we normally use Q with an apostrophe at the top. This will be any number that cannot be written in the form of A over B, where A and B are integers and B is not equals to 0. Remember, I said you must still pack what happens when B is 0. We found that it's a math error and we said we're going to investigate why that is the case. So you need to pack that until we get there. The new operations that we add here are a square root and a cube root. And that's what we talk about when you say these are non-recurring numbers. So if I want to show that this is not a rational number, right? This simply means that I will have 0,23546 is equals to x, right? Remember I said you introduce the concept of x. But now, do you see that if I multiply this by 100, it will never give me a point where I can get a repetition of the pattern that I have here. Because the whole point of multiplying by 100 is to get a repetition. So if I multiply this by 100, it will give me 23,5462. Look at this. Now, these are no longer aligned. Do you see that? These are no longer aligned. If I multiply it by 10, it gives me 2.35462. These are not aligned as well with this one. You see, they are not aligned. So that's how you then look at the concept of a number that's an irrational number. So these numbers cannot be written as a fraction, right? You cannot write them as A over B because they need to be non-recurring and they need to be non-terminating, meaning there's no specific pattern and there's an infinite number of terms after the decimal. So that's what we are looking at in terms of irrational numbers. Guys, I want us to take a quick ad break. And then when we come back, we are now going to answer the big question as to why do we get an error when we are trying to divide by 0. Please stay tuned. I'll be back just now.